it goes. All right. So how's everyone doing? Doing good? Surviving? Honestly, everyone's doing all right? Okay, good. How went your catapult? Well?
Yeah, once you figure out the nodes, it was like, it actually took me about 10 minutes to do the actual animation.
Good.
And I spent most of my time on like textures.
Good. Okay, good. You know, it's important, whatever we're learning, it's important that we go through the entire process as many times as we can, right? Because that's how we really galvanize and strengthen our skill set, is by repetition. There is some legit muscle memory that we are trying to create in all these crazy iterations, because that's how you learn it, right? And that's how you get to a point where you're not even thinking about the process, you're just creating. This is the hardest part of your kind of professional development in this world, because you're still trying to figure out and struggle with the tool set and the process. And the creation element kind of gets pushed down pretty quickly, because you're not creating, you're exploring, and that's tough, okay? It will get easier and it will get better. You know, we're not too far off from a process where we can just start, you know, kind of running a little bit. We're still walking, stumbling, scraping our knees, okay, with this whole thing. But we'll get to a point where you'll start running and charting your own course here. Well, if you have any questions about the catapult rig and render, please make sure you get those answered today. It's important that we move on from these projects, okay? Don't let them sit. Don't let them kind of snowball out of control. I know the inclination, okay, and that's to not turn it in until you think it's perfect, okay? Nothing's ever perfect and done, so just make sure that you know, getting some points in the assignment book or the grade book is a whole lot better than getting no points in the grade book, okay? So get it in, get it in. This week, we're going to kind of build on what we talked about last week, okay? If you really take a step back and look at the core concepts of last week's conversation, we focused on creating our first kind of control rig, where a whole series of independent parts and pieces were moving and influencing each other. Well, today we're going to add in a new layer on top of that and talk about set-driven keys, okay, which is an important part of creating, it's an important part of creating small little packages of rigged data, okay, and packages that we communicate to our animator with little sliders, okay. I have a great example that I'll show you here in a minute. We basically have two assignments this week. Both are rigging assignments. Well, one is absolutely a rigging assignment, and the second, let's just go into it. Let's go into the week 3. Oops. All right, so let's go into week 3. And there it is. All right, so we have two things. We're going to work on this set-driven keys in class today. This is probably something during our lab time that you can knock out and finish. Okay, we'll come back to that here in a minute. So we're going to focus our new stuff on set-driven keys. Then we're going to spend some time talking about some animatics. Okay, after our break, we're going to take a step back and we're going to start physically building our first little short film. And I've lovingly named it the Alien Invasion, right? And we're going to prototype, create an animatic for a very, very simple narrative that includes directly some very defined rigged elements, okay? I think it's important that we continue to practice the craft of filmmaking. And so our latter half of our conversation today is going to focus around some of those filmmaking ideas that will hopefully help you start crafting some really good animations, okay? So kind of a, technical and creative stuff today. We'll do some technical stuff, and we'll do some fun stuff with the animating and filmmaking. Absolutely. Yeah, absolutely. I can't imagine me not live streaming at all this semester. It may be like week 13 will be the first non-live stream day, Yeah, everything gets live streamed this semester.
So if I revert back to those both weeks,
it's been helpful, right? Yeah.
It's not like I go back and I'm like diligently taking notes on the whole thing. It's like I'll jump to a specific section.
Yeah.
Where was that one setting?
That little nugget. Yeah.
Fine.
Yeah. And I think that you've touched on my whole kind of passion for doing this for you guys, because there is often that one little button, that one little preference, that one step that you have forgotten that the entire building, if you will, is built upon, right? And if you don't know where that one thing is, it's impossible to finish your assignment.
There was a setting you'd gone over, and while you were going over, Moto crashed.
Yeah.
And I was trying to get back.
Catch up,
and I missed
right.
it.
Yeah, I hear you. Like, honestly, I do. So it's an important thing, these live streams, especially for this class. I think you're going to really start to value the role of the live streams when we get into our character rigging section, because we got 2 more weeks, I believe, and then we're going to start really jumping into characters. And you're going to find pretty directly that characters require a huge sequence of steps to get through. So the live streams are going to help you get back into that sequence.
I see that on the alien invasion
Uh-huh.
schematic that it does not come with any models. Are we going to be modeling our own spaceships?
You can. Yeah. We're going to be making an animatic this week.
So does it not include actual models, or?
We'll come back to that in a minute. Yeah, absolutely, for sure. The answer to that question is, yeah, we can include some models, and I can help you with that. But you're going to be building some of your own things as well. All right. I am super disappointed. There we go. Okay. I'm not going crazy. I thought I was going crazy for a second. All right, so I'm going to place something on every single one of y'all's desktops. This is a file that you've seen before. This isn't anything new. If you've taken GCOM 401, this is the classic Motobot example. All right, so in 2 seconds probably, boom, it should be on the desktop of all of your machines. Go ahead and open up the project file. This is an older project file, but I think it does a really great job of showcasing exactly the purpose and the idea behind set-driven keys. Okay, so it should be called Motobot Start. Go ahead and take a look at it. I'm going to do the same. Yes, sir. You didn't get it on yours? Kevin, what computer number are you? It's in the upper right-hand corner of your computer screen. It should say right-hand corner. There you go. 16. Okay, let me individually do it. Oh, yeah, yours is not even showing up. There it goes. Got it now. Does anyone else need the file, the Motobot file? Cool. Let's take a look-see at it. All right, so here it is. Dun, da, da, da. Here is our Motobot. Okay, Grant, would you mind doing me a favor and just maybe hit 2 of the 3 lights, the first 2? First 2. Or that works too. Perfect. Perfect. Okay. That way we can see our screen in here. Okay. So if you've taken GCOM 401, this is actually one of the project files that I use in that class. It's kind of an old school project file. It's been around for a long, long time. It's probably, oh man, I'd say this goes back to like version 4 inside of Moto, right? And I like it because it's a pretty cool, fun little project. However, if we start to break down and looking at its animation control surfaces, and specifically the control rig for this little character, man, there's a lot of advanced stuff going on behind the scenes. And I'm going to start breaking down and exploring how we're going to be able to build and take advantage of something very similarly, okay? Before we go too much further, I have to apologize. My allergies are going nuts right now, okay? So if I sound stuffy, I apologize. My allergy medication has not kicked in quite yet. All right, so let's take a look, because there's some cool things in here. Of course, this big purple ring is going to be the master controller for the rig itself. Okay? Now, check this out. Now, I want to do this again so everyone can see this, because this is part of the magic of the Moto rigging system. When I clicked on that purple ring, what happened immediately without me getting in the way? Yeah, so the ring gets highlighted, but in addition, a tool gets fired off too. That's pretty rad, right? Saves our animator an extra step. And we, as the rigger, we get to tell the animator which tool that they're allowed to use to work on this specific control rig. Okay? So that's pretty neat. I like that. I like that a lot. Now, how we do this, it's really easy, actually. You select, it's already going. There we go. You select your ring, your locator, because that's all it is. And then it's under this assembly section. Check it out. We have this utility tab here in the assembly section that allows us to fire off basically any command inside of Moto when this thing is clicked on, which is pretty rad. Okay? Now, I'm going to guess that most of you probably don't know the actual programming language that fires off these tools. Okay? I don't even know most of the commands, the actual back-end database commands. Here it is, tool.set, transform on, okay? But the developers down at the Foundry have given us a really great little menu here that kind of highlights some of the most used tools that they think that we're going to need. So if you click on it, here they all are. Here's the transform tool, move tool, channel haul, which we're going to talk a lot about today. Okay, that's going to come to the surface. Point being, this assembly section is where we can go to automatically fire off a tool when this locator is selected, and that oftentimes saves a couple extra steps. We haven't talked about macros, which are ways to take very long sequences of steps and condense them down into one script. Okay, I've seen a lot of macros be automatically funneled into this assembly section so that a huge sequence of operation now gets fired off when we click on one locator inside of Modo. Okay, so this assembly tab can get real powerful really quickly if you're comfortable working in the back end of Modo. Let's zoom back out and continue to take a look at all the other really important highlighted things in here. I want to focus on the wings, okay? Because check it out. What happens when I click on this dot that says wings? Yeah, something pops up, and it's this thing, okay? And check it out. I want to zoom in just a little bit so you can see them. What these are called custom user channels, okay? And each one of these custom user channels is controlling a whole series of animation channels, okay? So these are little sliders that our animators get to monkey with and to control the rig with. So I'm all zoomed in, so it's going nuts. But if I was, you can control the sliders one of two ways. You can either put your cursor here on the words and then left click and drag, or you can click, again, I'm all zoomed in, or you can click on the actual dot. So two different ways of controlling the sliders. And you can see that for this first one, yeah, that's pretty neat. I can control the animation of the wing just with this one little popover form, as it's called. These custom user channels allow us to expose specific animation channels or collections of animation channels and program them into a slider, basically, so that we can control them easily. Keep in mind the big focus of a lot of these control rigs. We don't want our animators going in and touching stuff, okay? We only want to expose the parts of the machine that our animators are allowed to mess with, okay? Because they will break things, they will destroy the rig, and that will be problems, big-time problems inside the context of our production pipeline. This is like when you're in your car. The developers of your radio have only given you access to a couple different buttons that control the radio, right? Because if it was up to us, if we had access to all the core circuit boards and stuff, we'd break our radio pretty instantly. Yeah, you can zap yourself, okay? So it's kind of in that thinking. So our conversation today is going to revolve around, see, isn't that cool? We can twist it that way, twist it up. Our conversation today is going to be about making this type of animation or this type of rig. These are called set-driven keys, and it allows us to go in and make defined relationships between a whole series of animation items and their associated animation channels, okay? And it's pretty easy to set up, but it's incredibly powerful when we start looking at it in the grand context of stuff, okay? So let's take a step back. I'm going to return to Canvas just for a brief moment, and I'm going to download the catapult rig that I gave you guys last week. We'll start off the day with a small little refresher on how we put some of these big pieces together. And I'm going to see what I can add into this. I'm going to see if I can get a slider that can control the movement of my catapult arm as a set-driven key, right? Because if you think about it, if you were playing around with this last week, well, let me just show you the big problem that we're trying to solve here. All right. Here's the catapult. Let's unarchive it. Excuse me. Let's open it on up. There it is. Okay, so one of the big challenges that we have with this catapult is the arm itself, okay? Because check it out. There's really nothing inside the animation engine at the moment that's going to stop the arm from going past some of the geometry, okay? You know, this kind of penetration into other geometric meshes, it's not the worst thing on the face of the planet, but if we can avoid it, we should try to avoid it, right? This is one of those things that instantaneously breaks the illusion, okay? We're no longer pretending or now believing that this is computer generated, okay? Yeah, we want to try to avoid it. So there are some rigging ideas, these set-driven keys, that will allow us to create stop points and start points, a defined area in which this item can animate within. And set-driven keys are a great application to get what we're after. So here's my goal. I want to create a whole series of set-driven keys that will stop the animation of this arm right about there on that big block. And I want it to, let's see, the other extreme pose is probably, I don't know, right around there-ish. Yeah, that's pretty cool. So I just want it to be able to go foomp like that. Cool, right? That's the goal in all of this, all right? Let's see if we can go the full distance here, okay? I'm going to do one wheel like I did last week, just kind of as a refresher of some of the ideas that we talked about. Because as I mentioned, all this stuff builds on top of each other, okay? So it's good to get a little bit of a visual refresher. Now, I want the wheels, okay? I want a main controller for the catapult, the wheels to rotate independently from the base, the arm to rotate independently from the base, and then we're going to add in a series of set-driven keys that defines the range of motion for my catapult arm, right? So where should I start? The wheels. I think this is an excellent practice. Separate out all the polygons into their own defined items, and that's a good place to begin. Just start separating things out. It's also going to help you as the rigger start to understand literally the moving parts and pieces, okay? So it's a good place to begin. I'm going to go down. I'm just going to grab some stuff here. Grab all this jazz. Yoink. Command X. I'll make a new mesh by hitting the N key on the keyboard and paste it in. Let's be good stewards of our scene. So this is wheel, front. I think it's the right one. There we go. Okay, so I'll go back to my catapult mesh item and unhide that geometry so I don't accidentally lose it. So let's jump over into the Setup tab and start looking at what we need to change to get the rig to behave the way we want. So as riggers, what should you next be thinking? I started to separate this out. What's the next step? Center points, absolutely. Because as we've talked about, the center point, and more specifically, the pivot point, really truly defines the area of rotation, right? That's actually where the geometry is rotating around. So we need to get that set and dialed pretty early on inside this process. Let's do it. How do I do it? Yeah, so we can use the Workplane. I think the Workplane is a great way of kind of getting some accuracy. Okay, so I'm going to do two things. I got my trackball rotation on right now. Does anyone remember where the master switch for trackball rotation is?
It's in the
Motor preferences, right? Moto preferences, and they moved it in the 12 series. It's down under remapping. So trackball rotation is right there, okay? And I also do override viewport level trackball rotation just to make sure that every single viewport has trackball rotation turned off, if that's what I want, and that's what I want. All right. Okay, all right, so with that done, now I can start leveraging the power of the Workplane. I'm on the mesh item called wheel front right. I'm going to just do a quick double click on that interior edge loop, which selects it. And I want to move my Workplane to that selection, okay? How do I do it? How do I move the Workplane to the center of the selection? Click the Workplane button, you got it. Now in the 12 series, they've made a small change, okay? And this is actually a change for the better. I actually really like this change, okay? Because when you turn it on, you set the Workplane to the center of the current selected component, right? And then, just clicking on it again will reset the Workplane to its defaults. Does anyone know where the default location of the Workplane is? The origin, yeah, it's the origin of the scene. It's a little confusing at first, right? But the origin is the home of our Workplane. So I'm going to set the origin of the Workplane, the center of the Workplane, to the center of the selected edge loop. There we go. Ha-ha. Okay, so What's next? You got it. So how do I select my center point? You got it. And I think what Dominic is pointing out here is a really important missed step initially for a lot of folks. You got to make sure that you're working on the item that you want to change. And sometimes, it's a little deceiving. I'm on the catapult item, and the center point's at the origin, right? Visually, the location of all the center points is the same. The default location, it's the origin, right? So just make sure that you're on the item that you want to adjust, okay? So I'm on the item. Where am I going up here to select my center point? Yeah, it's that one right there, okay? Center point. Keyboard shortcut 6, I believe, 6 or 7? 7. 6 is the pivot point, center, 7 is the center point. Ugh, can't talk this morning. All right, so with that selected, and I get some good visual feedback that my center point's selected, what's next? Yep, so I'm going into my toolbar. And in the setup tools, down towards the bottom, boom, you got it, to work plane position. So I'm setting the selected center point to the work plane position. That's the kind of logic flow that we're using here to determine what's happening. One thing, the developers down at the Foundry are starting to really bring to the surface these category dividers. I think they do a really good job of helping us understand the role of all of these tools and at times the output of what they're going to produce. So don't ignore these category labels, okay? All right. Aha, there it is. Wonderful. What's next? I'm so glad someone said that. Yes, we're going to turn off the work plane, right? Because the entire Modo universe is centered around the influence of the work plane. So if we have adjusted the work plane to some crazy selected angle, all of our tools, and check this out, all of our viewports are going to reference that crazy angle. If you don't reset your work plane, check this out. I'm going to change the view of my 3D scene to the top. Is that the top of my model in world space? No, right? If I look at my scene from the right, is that the right? No, okay? So it's even the orthographic views are dependent on the location of the work plane to define their function. So, at the core architecture of Modo is the work plane. Everything is centered around the work plane. So once I turn it off, you can see that now we're looking at my catapult from the correct view inside of my scene. All right. Okay, I'm going to deselect my wheel. And then what's next? What's next?
Oh, we have to iron into the catapult, but we don't have a catapult control rig.
Yeah, hold on a sec. I like where Grant's going. What are you trying to do when you select the Y key?
I'm trying to make sure that the wheel is doing what I designed it to do.
Bingo. We're going to test it. Before we move on, okay, we can't assume that we've done our job correctly, and we need to test the rig before we move on, right? Because now is the perfect time to make any changes and resolve some bugs. So the Y key fires off the item transform tool. Yeah, and I'm just testing it. Yep. I'm rotating it the way I want to rotate it.
Quick question. Is there a way, well, probably not, but I'm going to ask you anyway. Is there a way to where you can do that for all four tires or all four wheels at one time? Or you
I don't
just
think so. Yeah. Yeah. Because if you think about it, when you're setting the center point for this wheel, you're setting it to a very defined coordinate location in 3D space. That location is different on all four wheels. So this is probably one of those areas where, yeah, there's some labor involved in this, There really is.
No, that's cool. I'll just.
Okay. So let's, what's next? Dominic had the next step. I separated out all my moving parts. What's next? Locator, right? That locator is going to allow us to create the master controller for our catapult. Let's do it. So this is the locator button inside of the setup tools. What's the default location of every locator? Origin.
Is that just kind of the default location of everything?
Yeah, it really is.
Unless you
Yep.
change the action center?
Yep. Okay. So last week we talked about making a big ring that went around the outside of our catapult to make it really easy to select and move our catapult, right? How do I do that? You got it. So there's two areas in here that we need to look at. I'm in the locator properties. The shape. Yeah. Make a shape into a circle. So I'll do a custom shape. You can do any shape you want. I think you're going to find that circles and squares are a pretty good place to begin. It's very tiny at the moment. I don't want it solid. And I'll increase the radius. Let's put it to 1 meter. Not big enough. Let's put it to 5 meters. How about 10 meters? There we go. That's good enough for me. Now, one of the things that I like about Moto, and this is something that's different from other rigging systems, is that they give us the ability to offset the location of the ring. Now, this is, but what it's not doing is physically moving the locator, right? It's just offsetting the ring shape, which is pretty neat. This allows us to put the ring wherever we want without having to change the location of the locator. So I'm going to move my ring up a little bit. Somewhere right around there. I'm happy with that. That's pretty cool. Haha. All right. So let's give it some color in the display properties. I want to make a user color, and I'm just going to make it a nice shade of red. There we go. Ah. I know it's difficult to see on the projector, but hopefully easy to see on your screen in front of you. Now, let's go and add that assembly section that we were talking about a second ago, because it'd be great just to be able to fire off the Add M Transform tool the moment that this locator is selected. Okay. Now, I have the locator selected. So under the Command pull-down menu, I'll just do the Transform tool. Okay. So now when I click on this locator, poof, what pops up? Item Transform tool, which is pretty neat. Saves us a couple little clicks. Now, this locator isn't attached to anything, so what's next? Yeah, now we have to start making some direct relationships, and for us, that parent is going to be what we're after. Let's give it a good name first. Let's call it Master Controller. Okay, so how do I parent things to one another inside of Moto? It really is that simple, isn't it? Let's test it. Always test it, right? We complete a step. Okay, we didn't break anything. That's what we're after, right? Woohoo! Okay, so let's get that wheel working. Talk to me about the wheel.
We have to go into nodal changes, and we have to.
What's that called? The nodal viewport, the schematic viewport. Now, for me, I've maximized my 3D view, so my schematic has been kind of minimized, but it's always there in the Setup tab. You can't get rid of it. So, bloop, there it is. Ah, welcome back. All right, so this is where it gets fun, right? How am I going to work with the rotation channels of this specific object? Because that's really all I want, is just the rotation.
Go to the channel tab in the right.
So the channel list, okay.
And then you want to go down to the rotation, the world rotation.
World rotation, that's a good place to look as well.
I think you should start at the Y.
Yeah, here's another way you can do it, okay? Because really all that I want to influence is, let's just double check, make sure it's the, yeah, so I want to influence the rotation along the x-axis. That's the direction that this wheel is going to work on. So for the wheel itself, I'm just going to grab, see how I've selected that channel? Okay, you click on the background here and it selects it. Try to be disciplined in your mouse click locations. If you start clicking on the dot, what is this going to do if I clicked on the dots? It's going to keyframe it. I just want to select the channel. I don't want to keyframe it. So if you click on the background here, it makes it a little bit easier. Okay? With that channel selected, right-click on it, add channel to the schematic. And there it is. Now it automatically loaded in the item and the animation channel that I want to influence, okay? Did I do Y? Okay. So let's break it. Remove nodes. Don't need that anymore. Yeah, that would have been a funny animation. Clicked on the wrong one. All right, there we go. Okay, so there's the rotation X channel that I want to influence. Now, what's going to be influencing the rotation of my wheel?
The movement of the catapult.
The movement of the catapult. So when I move, when I translate and change the position of my catapult, I want the wheel to change its rotation angle. Okay? So specifically, we want this master controller to be the driver of this entire animation, right? Now, what part of the master controller do we want to use?
Like the location, so specifically the movement.
You got it. The world, yeah. Because we don't want its local position. We want its understanding of where this catapult lives in the world space, okay? We get access to that in our channel list once more. This is just a spreadsheet. There we go. There we go. And we got world position, world rotation. This is what I'm after. So I just grab world position, and you can actually just left click and drag it in there, which is pretty cool. Okay. You don't necessarily have to do right click, then add to schematic. Just drag and drop from the channel list, which is kind of cool. And we can start wiring this together. Yeah. So the modifier that we're looking, the translator between position information and rotation information in this specific case is called the Revolve modifier, right? We're going to go to get access to that Revolve modifier. Add drop-down menu. Yes, good. And then it's in here. Revolve. Boom. Okay? And now it's just a simple process of wiring all the inputs and the outputs together. Pop quiz. Which side of each node is the input side? The left side. You got it. It's always going to be the left. This is in. This is out. Okay? So I want to feed the locator's position into the modifier. And I want to send, so it's going to do some thinking for us, right? This is kind of like a translator, if you will. Okay? And now we're going to take the angle output and feed it over there. Okay. Let's test it, because we've done some work. We always want to test it at the conclusion of each step just to make sure we haven't broken anything. And it works. And it works. Let's add in a layer here. This isn't something that I talked about last week, so this is something new, okay? Because we can gain some accuracy in our Revolve modifiers by adding a couple new elements into the mix, okay? If we explore the channel list on our Revolve modifier, there's an additional few channels that are not visible in the actual node itself. Specifically, the radius. That right there. Now this defines, this defines in every sense how wide our wheel is, and the math that determines the rotation of the wheel is based on the computer's understanding of its diameter, or in this case, the radius, okay? How big is my wheel? I don't know how big my wheel is. I would like to have a little bit of accuracy in here so the wheel rotates kind of appropriately, right? So I want to go and start influencing this radius channel here, okay, to get the accuracy that I need, because I want the size of my wheel to be reflected here so the math and the rotation translation is correct. So let's get this into my schematic by dragging and dropping. And now, check it out. In the Revolve modifier, we have a new channel. Well, it's not a new channel, but we've exposed that radius input, okay? And this is going to be a variable that will determine the angle output. See how it only has an input node? So that means we've got to feed something into there. We're going to feed a value. Now, I'm not a computer scientist. I'm an animator, right? If I can figure out a way to do this visually or have the computer do all the high-level thinking for me, I'm always going to go that direction, right? Because I'm sitting in front of a gigantic thinking machine. I want it to think for me. So check this out. This is a cool little trick. Now, is there anything that we have been exposed to so far that defines a radius? Have you seen the word radius pop up at all in the last week or so? We've actually influenced it today already.
Didn't we influence the radius of the controller?
Bingo. Check it out. One of the properties on our locators, okay, because remember, I made a custom shape property. It's a circle. And if you look at one of the properties in here, boom, radius, okay? What if I made myself a fancy measuring stick where I visually used a locator to define the size of my wheel and fed that information through my schematic into my Revolve modifier? That would allow me very quickly to get the information that I needed. And it allows me to do it in a visual way. It allows us to repeat many of the sequence that we've gone through already. Let's check it out. So now I'm going to create another locator, okay? Create a new locator. It's at the origin, and I don't know, let's just call this wheel sizer. Because the whole function behind this wheel sizer is to figure out the radius and the size of my wheel. Now, I need this locator, this one right here, to be in the exact same location as the center of my wheel, right? I want some accuracy here. How am I going to do that? Workplane. Exact same sequence as we went through when we initially set the center point for our wheel. So let's just do it real fast. I'll go back to my wheel, grab the edge loop here, assign my work plane to the center of the currently selected component, and now I'm going to go to my wheel sizer and do the exact same thing to work plane position, boom. There it is. It's in the center of my wheel. I'm going to change the shape this time to a custom shape. I'm not going to choose circle. Oop, zoomed in a little too much. I'm going to use cylinder. Okay. It's a very small cylinder. Yeah, and it's pointed the wrong way. It's kind of hard to see because it's ghosted. Can you guys see it? Yeah, it's in there. Okay. So let's get it facing the right way. There it is. I'm going to make it not a solid one, so it's a little bit easier to see. And now I have a measuring stick. Okay, let's turn off my work plane. And let's look at the scene from the left view. Now I can see the ghosted white circle, the wireframe of my radius, or excuse me, of my wheel sizer. And I'm just going to make the radius value here generally where I want it to be. Right about there. Voila. Now I have that value. Okay, I've captured the total radius of, I'm upside down, excuse me, of my wheel. Okay, let's wire this into the rig. Okay, there's my wheel sizer. I'm going to grab that radius channel, and drag it in. This is now going to feed that. Okay. And now the math, the rotation parameters of my wheel are going to be exact. Okay. If if function of this wheel sizer is just a gigantic measuring stick, I can just turn that off. I don't really need its visibility inside the scene. It just helps me figure out. It helps the computer figure out the math in a visual way, which is kind of nice. Okay, because my wheel was in fact bigger than the default, which was 1. Its radius was 1.39 or almost 4, I think, so not wasted time. All right, pretty cool, huh? A nice little extension, nice little added benefit from last week's stuff. Which brings us to this week's stuff, okay? Working with set-driven keys, okay? If you remember, the intention behind this process is that we want to go in and establish a start and a stop point for our catapult swing, okay? I want to produce the illusion. There we go. I want to produce the illusion that, oh, oops. I'm in edges, excuse me. There we go. I want to produce the illusion that, boom, right at that block, I want to stop the animator from going past that block right there. And I want to make sure that it doesn't swing down any further than, something like that. Okay? So that's it. That's the total extent of the animation that we're going to have our animators do, right? Can't go past those start and stop points, okay? Now, in order to do this, we need to go in and create a couple of things initially. First and foremost, we need to create kind of like a warehouse. We need to figure out, something in our rig that's going to be the home for all of this animation information, okay? I like the idea of having the warehouse be on my master controller, because it'd be cool, right, to have like one little mechanism that the animator fools around with, right? He just selects that ring, can rotate and move it all around the scene, the wheels will rotate automatically magically, and you can also control the arm from that one master locator. That's a cool, simplified rig. So maybe the location for all this custom information is going to be on this locator, okay? And out there in the real world, this is a good practice to follow. Generally speaking, we don't want anyone outside the 3D modelers and the riggers touching the actual geometry. If there's something to influence, it should be done at the locator level, right? Because it's really, really easy to mess up the model when you're monkeying with the actual mesh item, right? All it takes is one, buttery finger slip, and now you're moving actual geometry, and that could have a rippling effect throughout the entire production if we're not careful, right? So messing with locators is the preferred way of doing all this. So I'm going to work on my master controller, and the first thing that we need to do is create a custom user channel, okay? This is going to be an animation channel that contains a relationship between other animation channels. And this channel is going to be the little slider thing, if you will, like we saw in the example file earlier, that our animator is going to work with. Now, this is going to happen inside the Modifiers tab, okay? And here it is, Add User Channel. You can also get to this, by the way, in your channel list. It's down here at the bottom. I kind of prefer going and hitting the button. The form that pops up is a little bit more clear in what you're building than doing it in the channel list. And you get a gigantic button, which is kind of nice. I like buttons. Okay. So let's add a user channel. This is an animation channel. So we'll be able to go in and keyframe it and do whatever we would normally be able to do on this custom animation channel. So as one might imagine, we got to give it a name, right? So let's just call this arm swing. The channel name below, this is what's going to show up in your channel list. So let's do a good spot check. Notice that the computer is automatically taking out the spaces, so just be mindful of how things are showing up, okay? Some people don't like having it all be one continuous string, so you're more than welcome to go in and do things like that if it makes it easier for your brain to decode all this information. Now, the type of animation data here is really, really important. And this is where it gets a little bit overwhelming, okay? Because there's a lot of there's a lot of information that we can program, and there are many, many, many different types. And a lot of folks, they start looking at this crazy list and they go, I'm out. I don't even know what the differences between all these are. Some of these, I don't even know the difference between them, but there are some rock stars, some all-stars in this list that are really important for, I think, everyone on the face of the planet to understand, okay? So float, okay? Let's talk about float. I'll write this on the board so folks can get a good understanding of this, all right? So float. When you see the float data type, what is this?
Floating point.
Get more specific.
Decimal point.
So we're
precision,
No, you're absolutely right. And I think maybe the easy way of describing it, numbers, right? We're working with numbers. So we're working with numbers, and as Kevin pointed out, that has a decimal point. So the value that we could program in here would be like 1.236. Very granular. We can get incredibly specific with float values, okay? So this would be a float value. Something that includes a decimal point. And the type of float will determine how many decimal points that we get to play with, okay? Now, what's the data type of just a single number that doesn't include a decimal point? Integer. So an integer looks like this. So it'd be just like 1, 4, 15, just whole numbers, okay? That's an integer, no decimal points. You can find the integer down here towards the bottom. Now, the other one that I want to draw focus to in the context of this class is, of course, percentage, okay? What would percentage be? Simply 0 to 100, and that's the range that we're going to be working with. It really is 0% through 100%, okay? Those are the three that I want to focus on today. There are obviously a lot more. You kind of get to see the back end of Modo and really get a good understanding of all of the different data types that the developers get to play with, including like speed and acceleration and divider, whatever that is. I really don't know what that is. So it can get pretty advanced pretty quickly. So in the context of our little animation, we get to pick, or we need to pick, which data type this little custom user channel is going to work on. Now, my animators are pretty simple, and this is a pretty simple rig that we're trying to make. Maybe percentage is a good place to begin, right? 0% will be down, 100% will be up. You can't get much easier than that, right? That's a good place to begin. It's either down or it's up, and then we can only animate in between those two start and stop values. That's a cool place to begin, right? So I'm going to choose percentage. The default value is going to be 0. And I always like to, upon creation, to set the minimum value and the maximum value. Okay, these are the extents. Because if you don't, I can go to negative 8,000% to positive 4,000,000% if I'd like, without defining that start and stop point. So I'm going to tell Modo that the maximum value here is going to be 100%. And FYI, you can change all of this after the fact too, but knowing what we make, before we make it is always really helpful. All right, let's hit OK. Oh, it didn't like the hyphen. And there it is down there at the bottom. I'll make this a little bit bigger so you guys can see it. All of our custom user channels are going to end up in our channel list, and they're always, always, always going to be at the bottom of that channel list, okay? And in the order that we create them, and they're not going to list them alphabetically, okay? So there's arm swing. We can see that, good job. It's coming up as percentage. Well done, okay? This is where we get access to it, okay? The channel list is a list of every single animation channel that currently resides and is influencing the selected item. So I have that locator selected, so I'm seeing just this locator's animation channel. Now, I want to work with this animation channel. I want to make a custom relationship between that individualized custom animation channel that I just made and the rotation of the arm, okay? This process is called set-driven keys. We're making a relationship now, and I'm defining the start and stop point of the rotation of the arm based off of the percentage of my custom user channel, okay? And it's pretty fun. It's pretty easy to do. Let's check it out, okay? We need to load in a new menu. It's going to be in that modifiers menu still. Channel links, okay? Because we're linking two things here. We're linking my custom user channel, arm swing, to the rotation of my arm, okay? I'm making a link between them. So we'll go into channel links. You'll get this cool little popover. And now we need to make some decisions here, okay? So there's two columns. This is the driver column and the driven column. So this is kind of like the thing that's going to influence and the item that's going to be influenced, okay? So what do we want the driver of this relationship to be, you think? Yeah, someone said it. It's the custom user channel, the thing that I just made. That's going to be the driver, right? Whenever I switch, the percentage, I want my arm to swing, okay? So the driver is going to be the custom user channel. So I'm going to load the driver, and we can do it simply by selecting it over here. I'm going to load it in, bloop, and it pops in on this form. See, this is kind of a, an itemless selection, or you just got to select the item. You can also do it in the OpenGL viewport. It will work the same, okay? And now, because remember, this locator has the custom user channel. It's the warehouse. It's in here somewhere.
I think it's the wrong.
Oh, I grabbed the wrong locator. Thank you. Thank you. I put it on master controller. Let's load that as the driver. And there it is down there at the bottom. Okay? So the master controller is the warehouse of our custom user data. Okay? My animation channel's on that locator, so I've loaded it as the driver. What's going to be the driven?
The arms rotation.
Yeah, so the arm. So we load in, we select it, we load it in. Now, we have to start making some, so we've loaded in the items, that's the first step. The second step is to start to make the relationship between the two different channels themselves, okay? So I want the arm swing animation channel to influence the rotation, rotation X of my arm, okay? So I need to manually select these two. Yoink, yoink, okay? If you kind of look at what we're doing here, we're getting very specific, right? We're grabbing items, now we're grabbing animation channels within these items, and now we get to set what type of relationship we're going to have. And this is the part that people often miss. And if the developers of the Foundry are listening to my live stream, this is a great opportunity to change the visual hierarchy of these buttons because they don't really speak that they have a defined role, okay? We have two options. We have a direct link, or we have a relationship. Now, the direct link is basically going to take whatever value is here, and it's going to pipe it over there. We were doing that earlier in the schematic. Those were direct links, right? But I want to change the perceived relationship a little bit. I want to go in and customize where is start and where is stop, right? So what we're after is not an override of the animation data. It's a customization of that animation data. So I'm going to create a relationship, okay? And you'll see why here in a minute. Let's create a relationship between the two. They're now dating. So let's make it official. He liked it, so he put a ring on it. Let's make it that's a bad joke. Anyone Beyonce? No? Just me? Joke. Okay. All right, so let's add the link, okay? And we're going to get this cool popover, okay? And this is where it gets really kind of fun, because if you look very carefully, now we get to go in and program how we want this relationship to actually work, okay? And we do it with a whole series of keyframes, believe it or not, okay? So this is where it's exclusively visual, okay? We have two sliders. We have the driver. It's currently set to 0%, okay? The arm swing custom channel. And then, check it out. Here's the driven's rotation channel. So at 0%, where do I want my arm to be? Down. And I think I'm there, actually, which is a happy accident on my part, okay? So what we need to do is hit this gigantic button. Yeah. What type of button does this look like? It looks like a stop button, doesn't it? And again, if the developers are listening, this would be something to fix, okay? Because this looks like a stop button, right? And this stops a lot of people, especially given the context of where it sits inside of this menu, right? Because you got a back arrow, which kind of looks like rewind. You got a front arrow, which kind of looks like fast forward. Then you got a stop button. But what this actually is a create a keyframe button, okay? Because remember, in Modo, a white cube is our visualization of a keyframe. So we're going to key this in. Bloop. Okay, I'm all zoomed in, so I don't think it worked. There we go. Now, I'm going to go forward in time. I'm going to put that at 100%. What value do I want down here? I don't know. Let's find it. Something like that. Yep. I think that's pretty good. Since I already had a key on that custom user channel, it automatically keyed it for me. It did an auto key, which is nice. Okay? So when it's yellow, and you get a little yellow dot there, you've made a keyframe. Good job. Okay? Yes, sir. What's called a handle? So you hit, did you make the relationship button in your, and so you hit add link. Nothing came up. Hang tight, we can figure this out. I always like to test it, because if it works, yeah, see, something didn't get keyed here for me. Yeah, let's try this again. Key. Let's really key it. There we go. There it is. I did hit the button. It didn't auto key. And now it works. Yay. And I can get out of this window. You drop the tool. It's a tool. So you hit the space bar and it drops the tool. So now I've gone in and I've created kind of a custom little mini animation inside of my rig. I've told the rig, this is the start, this is the stop. Now once you drop the tool, where did it go? How do we get it back? How do we get access to that custom user channel?
Just under the master controllers.
Yeah. Whenever we want to get access to that custom user channel, we got to go back to the warehouse where it's actually stored. And for me, it's on master controller. And if I click on arm swing, okay, it's in there. We still don't have access to it yet, okay? Which brings up, now please note before we go any further that I have my custom user channel selected, okay? We have a tool over here. It's actually a pretty cool tool. It's called Channel Hall. Keyboard shortcut C. When I activate it, there it is. I get the little popover. And now I can start going in and working with it. Okay. So that's how we get access to it. It'd be great if we could go in and have it automatically pop up. That'd be cool, right? Maybe we can add something to our assembly. So I'm going to go back to my master controller. And then before I go any further, I need to have the channel that I want to have automatically pop up selected. Okay? The assembly section is pretty neat. And I'm going to do channel hall instead of item transform.
What happens if you don't select the channel and just went and click on channel hall?
Nothing. You're going to need an empty form. All right, let's see if it works. Ha! I deselect it. It goes away. Select it again. It comes back up. Pretty cool. Now, Adrian was running into a problem. He's like, how do I edit this? How do I physically go in and make this work? Maybe you messed up, right? Let's check it out. How do we edit our custom user channels? Well, channel links is going to be really our driver of this entire operation, okay? So if you want to get back to that little popover, there's a couple things in here that you got to do. You're going to load the driver and the driven again. There's the driver. There's the driven, okay? Let's find it. It will tell you which ones have the relationship. See how there's a little gray circle with an arrow? That's the relationship, okay? And it should automatically come up. And, well, I got channel hall. Now, to edit it, it normally just pops up. Why is it not popping up? There it is. This may be a small change in the 12 series. To get access to that little keyframing window, notice that after the link has been made, we have a modifier over here inside of our item list. Selecting that will get you the interface, so you can rekey it and make adjustments to it as well. If you really want to get geeky with this, and this is kind of shows you the power of this entire system, you can actually open up a graph editor, okay? And you can go in and establish different attenuation curves for your animation, which is pretty cool. I like that statement. There's more numbers here than I like. Yeah.
Like anytime when you say this is going to be all visual, sweet.
Yeah.
That's why I like it.
Yeah. Yeah, that's why I like Moto too. You know, Moto has always been a tool set, I think, for artists first. If you look at some of the other tool sets that are direct competitors, Maya is a great example of this. Houdini is another great example of this. Those are made for you know, artists that are more like engineers than they are you know, artists. So I've always appreciated that about the about the Moto tool set as a whole. I spend a lot of time in Maya, and there's so many things in there that I go, oh man, I gotta jump through like 8 hoops to do one thing that I can do over in Moto, right? So, anyways, yeah.
Question regarding the point of this whole setup was to have it so that the arm would only swing in a certain way and wouldn't clip.
Right.
Is there a way to kind of force the arm item to not clip with a certain other item? Can you force the polygons to not clip through each other?
Not with the rigging tool set, and not that I'm aware of. Okay. What you're talking there is rigid body dynamics, where the surfaces, basically there's a little machine put on each polygon on a mesh that prevents them from crossing over into each other. That's pretty advanced. We're going to get into that a little bit after the character rigging. We're going to talk about dynamics. You know, and this kind of speaks to one of the big challenges in 3D, and that's understanding what it is that you're trying to make, and then make the tool just for that purpose, right? That would probably be over-engineering something. I can get the exact same result with a set-driven key, right?
My thought process is kind of, I'm thinking in terms of games, how something that's always bothered me when I play games is that a lot of the time character models or environment models will clip into each other. Simply because the programmers and the designers, they can't design it so that every possible interaction, because there's no way that they'll be able to determine what 2 million players are going to do.
Yeah.
So I was just wondering if it's possible to force that so that you can't have a character model that's standing holding a weapon and they move in a certain way and their armor clips into their shoulder or something.
Yeah. Yeah, those collision systems are definitely available to us, for sure. In game engines, it's pretty easy to start doing collision and stopping items from penetrating through each other. That's pretty easy. It's different here in Moto, but we're going to explore that when we get to the rigid body dynamic system. All right, questions about this workflow, this idea. Let's go through it one more time real fast, because I think it's important to see the sequence, because rigging is all about sequence. And if we deviate from that sequence even a little bit, it's not going to work, okay? It's kind of the humbling part about rigging, is that you get immediate feedback if you've done your job right? It's not like, when you're waiting for a render to see what it looks like, got to wait 3 hours to see how well of a job you did. You know immediately if it's working or not working. So it's easy and hard in that regard. Okay, so let's go through this exact same thing again. And I think what I'm going to do this time, let's find something else to move here. I'll just do it on a wheel, because we can do the exact same thing on basically any item itself. Oops, wrong button. I want to extract that wheel onto its own layer. And let's get the center point kind of dialed real fast for that wheel. Select the center point, to work plane position, reset the work plane. Let's test it real fast. Rock and roll, rock and roll. Okay. So same idea. There we go. All right. So this is going to be fun, okay? This is going to be fun. So how do I create a custom user channel? Yep, it's in the modifiers tab. I've selected my master control locator because that's a good place to put a lot of this data, okay? Let's give it a good name. So we'll just call this wheel spin. Spib. There we go. Oops. So I do this a lot. Whenever I finish a line, I hit return. But in this case, it confirmed the creation of a custom user channel, and all that stuff went away. So it gives us a great opportunity to see how we can edit our custom user channels if you've messed up, as I just have. So here's wheel spin. It's not as visual as you saw before. So wheel spin, here's the default minimum value. All this stuff looks pretty good, actually. I got kind of lucky. And now we want to start programming that in. Okay? So whenever I change the percentage of wheel spin, I want that wheel to rotate. Okay? Yeah?
If you accidentally, if you accidentally use a percentage where you actually wanted something different, can you edit it from there, or do you have to delete it?
Yeah. I think, if I remember correctly, yeah, change user channel type. Yeah. Yeah, because now it's at float, or let's put percentage in there in case we messed up, you know. We're on our way. So let's start getting into the rigging of these custom user channels to that wheel. What's first? Where am I going? Channel links, okay, because we're going to link it to, we're going to link two different animation channels together. You got it. Now, this is cool. Check it out. The master control locator is actually in the driven spot. I can swap it. So that's kind of a nice little benefit. But we want the master control locator in the driver spot. Let me grab the wheel. This is going to be the driven. And specifically, let's just do something silly here. I'm going to rotate it around the Z rotation. Okay? So let's find the wheel spin channel. There's wheel spin, and we'll do, now if you don't have rotation, see how it just says position in here? We don't want to do the world rotation, right? We want to do local rotation for all of our items, right? Because if I want this to spin it around its local axis, not the world axis, which could give me some weird results. But right now, I'm only seeing position, local position data. So you can add rotation, okay? And then we can do rotation Z. Which of these two do I want? Relationship. That way I can key in a start and a stop point, okay? The extents of the movement for this item. And finally, add the link. So we define the type of link, and then we physically add it. We don't need this for the time being, so we'll come back to that in a minute. All right, so at 0%, this is where I want my wheel to be, so I'll key it in. At 100%, I'm all zoomed in, so it's wigging out. I apologize. At 100%, I don't know. Let's do 90. And I'll just make sure it's keyed. That's it. Okay? Cool, huh? Now we've made drop the tool. Now we've made the relationship. We can expose it. Now, it's going to add custom user channels automatically inside that form. I already had one created, which is great, and it's showing that any additional custom user channel in the popover form. But if we didn't have that in there, you know, it's in the assembly section. You just got to make sure that it's selected in your channels list.
So as long as one custom user channel has been hauled into the viewport, it will automatically add
Yeah.
any
Yep.
more.
You got it. Should, in fingers quotes. I've seen it break from time to time. It should. I always go in and,
But it is a program.
yeah, it is a computer. It is buggy, right? I've seen it break. Yeah, so just make sure you have both of your custom user channels selected, and then under the assembly area, it's going to understand that selection and bring those to the surface when you import in the command channel haul. Okay? And now check it out. I can control the arm swing. I can control my funky wheel spin. I've created a simple little kind of machine here for my animators to do their thing. Yeah, I'm distilling a lot of complex information into something that's very simple. Okay?
Imagine having like a flying catapult flying over and just launching.
Just phew, 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 phew. Yeah, and all this stuff is keyframeable too. So this is how we can make, you know, we're only doing it with one item to one item, right? But if you think about it, I can have one custom user channel control the rotation of all of my wheels, for example. Let me just do it real fast. I can show you specifically what I'm talking about. Yeah. You can, yeah, absolutely. Absolutely, right? We were talking about transformers before, right? And how all of those parts and pieces rotate around each other. Do you think the animators were going in and say, select piston, rotate it, this one, no. No, they did that one time, right? And then all that information was distilled, I can almost guarantee it, into a set-driven key. And then when the rigger handed the model to the animator, there's probably one slider where they went, car, slide over, Optimus Prime, right? You know, and it rotated and came out, you know, like it was supposed to. I can almost guarantee it. Yeah. Yeah, it can get pretty cool and pretty complex quickly.
Would you say that they pretty much the same thing like with Game of Thrones, the intro?
I'm proud to say that I have not seen a single episode of Game of Thrones. So, so I don't know. I really don't know. I don't have HBO, so I've never seen an episode of Game of Thrones.
I think
So,
the title sequence like does something or like.
okay, let's explore it because I'm curious now, and
It's the title season.
YouTube is probably going to take the live stream down. Actually, I'm not going to do this because I don't want YouTube to take the live stream down. Because I've seen them do that before. Like, hey, you got copyrighted content in your video. They pull it, and I want to make sure this doesn't get pulled. So I tell you what, let's stop the live stream, and then we can take a look at it, right? Because the next portion of our conversation, I'm not going to live stream because I can't.